On Friday, we learned how to convert from grams to moles and moles to grams using molar mass, which we found on the periodic table. It's different for each element. If we're looking at carbon, like we are in this particular problem, its molar mass from the periodic table is 12.01 grams per mole, or that's how many grams, 12.01 grams, are in 1 mole. We also learned how to convert from atoms to moles and moles to atoms, and that was using Avogadro's number. Now that's going to be one of our key words, is the word atoms. That's how we know we have to use Avogadro's number. 3 atoms in 1 mole. Okay, now what we're going to do is we're going to combine those two conversion factors and put them together to do one-dimensional analysis problem and go from grams to atoms or atoms to grams. So for this first problem, how many atoms of carbon are there in 0.020 grams of carbon? What I'm going to do is start with the number that's given to me in the problem, 0.020 grams of carbon. And I see the word atoms in this problem. If I see the word atoms in the problem, I know I have to use Avogadro's number somewhere. So I ask myself at this point, can I go ahead and use Avogadro's number? Well, you look at these units right here that we're starting with, it's grams. If it were atoms or moles, we could use Avogadro's number, but in this case, I only have grams. So what we need to do in this case is go ahead and convert grams to moles using molar mass, and then we can use Avogadro's number. So I can't use Avogadro's number now, so I must have to use molar mass. Gram is here, so gram has to go here, and there are 12.01 grams in 1 mole of carbon. Grams cancel. Now I have moles. Can I use Avogadro's number now? Since I have moles right here, I can, because I have either atoms or moles. So mole is here, mole has to go here, and in 1 mole, there are 6.022 times 10 to the 23rd atoms of anything. In this case, we're talking about carbon. Mole cancels out. Everything on top multiplied together, divided by everything on the bottom, 0.02 times 6.022, that EE button 23, and then divide by 12.01. Now, since we're using Avogadro's number, it's a good chance that my answer is going to end up in scientific notation, and it does, with my number that they gave us in the problem. That's the only thing I base my sig figs on. I have 2 sig figs because the others are leading zeros. So I need 2 sig figs in my answer. 1.0, and then I need to look all the way to the end of my calculator, times 10 to the 21st atoms of carbon. And that's the answer that we need with the correct number of sig figs. All right, let's look at this next one. This is kind of the reverse of the one we just did. It says, how many grams of silver are there in 3.76 times 10 to the 27 atoms of silver? Well, we know silver is Ag. Ag, it's only silver. I have atoms here, so I know I'm going to have to use Avogadro's number. I am going to have to go to grams, so I need its molar mass. The molar mass of silver is 107.87 grams per mole. And so now let's start our dimensional analysis. So 3.76 times 10 to the 27 atoms of silver. I see the word atoms. That's my key word in the problem. So I know I have to use Avogadro's number. Can I go ahead and use it now? Well, in this spot right here, I do have atoms. And if I have atoms or moles, I can go ahead and use Avogadro's number. So I'm going to go ahead and do that. And atoms are here. Atoms have to go here. And so it's 6.022 times 10 to the 23rd atoms in 1 mole. Remember, you will never see 1 atom or 1 gram when you're doing these. Atoms cancel. Now I have moles, but they want grams in the problem. So what I need to do is I need to convert moles to grams, and I do that by molar mass, which I get from the periodic table. We've already looked that up. There's its molar mass. Mole is here, so mole has to go here. And in 1 mole, there are 107.87 grams of silver. Moles cancel. Everything on top multiplied together divided by everything on the bottom multiplied together. Times 107.87 divided by 6.283. And the calculator spits out 673,515.8 grams of silver. I know I need to base my sig figs only off the number they gave me in the problem. That's 3 sig figs. So I go 3 numbers in, and then this 5 is going to make the 3 round up. So 674,000 grams of silver. And that would be my correct answer with the correct number of sig figs.